Hi, we've been looking at the discrete-time Fourier series, and we worked some examples, and if you're not comfortable with exponentials or complex exponentials, you may be wondering, how can complex numbers possibly be, or complex exponentials be mixed together to form a square wave or a sinusoid or, a triangle wave or whatever? In the previous video, and it's okay if you didn't watch that, it was an example video, and we calculated the Fourier series coefficients for a square wave alternating between 0 and 1. The pulse width was defined by this parameter n1, and the pulse width is 2 times n1 plus 1, and the period was n. We found the Fourier series coefficients to be a0 was 2n1 plus 1 over n, and the other AKs were this thing here. Now, it's important to remember that in discrete time, the Fourier series coefficients repeat after every n. So while this is a0, this is also a n, a 2n, a 3n, and so forth. Now, in my code, I've initialized the parameters. I just have to pick some parameters to define my square wave. So I pick, for example, 2 to be n1, so the pulse width is 2 times 2 plus 1, or 5. Then I choose the period to be 8, so the square wave repeats every 8 samples. Now for plotting purposes, I'm going to plot this thing from n equals -3 to 20, so that's roughly 3 periods, because 3 periods would be 24 samples. Okay, now x, I'm going to make the analogy of a recipe and baking and cooking some sort of dish. And so x is the bowl. We're going to mix together all of our ingredients in x. X is going to be the signal when we're finished. So I'm setting that to 0 to begin with. Omega, because there's nothing in our bowl. Omega 0 is, as always, 2 pi over n. Now I'm going to keep track of the coefficients, and this coefs, and these are the amounts of the ingredients. Okay, so right now there's 0 because we haven't calculated anything yet. So I'm going to make a new figure, and then in this loop, I'm going to go from k equals 0 to n minus 1. And remember, in discrete time, we only add up in our summation to synthesize x, k over 1 period. So I only need n terms. So this is in direct contrast to continuous time, where I need from -infinity to infinity. Again, for discrete time, I just need n consecutive terms, so I'm choosing to go from 0 to n minus 1 for a total of n consecutive terms. Now, if k is equal to 0, then I calculate that a0 term, 2n1 plus 1 over n, and then that's the amount of the ingredient. So then I take the amount, multiply by the ingredient, which is the 0th harmonic, add it into the bowl, and then update the bowl. So now the bowl contains this one ingredient. For subsequent values of k, this would be the else, I calculate ak based on this expression that we found in a previous video. That's how much of the ingredient. So I take how much of the ingredient, multiply by the ingredient, which is this complex exponential, add it to the bowl, and then update the bowl. And I do this, again, n times. And I keep track of the ingredients, or the amount of ingredients, so I can make a plot later. And so we're going to plot the bowl, the contents of the bowl, as we go along, and we're going to plot the real part and the imaginary part of the signal, of the bowl as we move along, and then we're going to plot the Fourier series. Now, I just want to, before we start, be clear of what we're doing. We're reconstructing a square wave that goes from 0 to 1, so it's purely real. 0 is a real number, right? And 1 is a real number. So after we're done with this, after we're done adding up all the ingredients, we should have 0 imaginary part. So let's see if that's what happens. So I'll run the program. Running the program gives me this figure right now. This is one ingredient. Here's the real part of the square wave. Here's the imaginary part. Okay, this is definitely not a square wave. This is just a constant, right? That's one term. That's the constant term. And the imaginary part is all 0. I'll continue. Here's 2 terms, 2 ingredients in our bowl. So you see the real part is starting to oscillate now, but there's this imaginary part that's also oscillating. And notice the scale on these things. So we're about 4/10, and this is about 1. I'll add a third ingredient. Okay, so we have this kind of funky looking thing here in the real part, and we have almost a ramp or a sawtooth in the imaginary part. 4 terms, there are 4 ingredients. 5 ingredients. So this is interesting. The real part is starting to look like a square a little bit. It's high for a little bit, then low, almost 0 and almost 1, right? But the imaginary part is still non-zero, so that's a problem. 6 terms, even more so yet, the real part is looking more and more like a square wave, right? And the imaginary part still is non-zero, so that's not good. Okay, 7 terms. Okay, now the last one is the 8th term. We chose capital N to be 8, so I only need to add 8 ingredients. Let's find out what happens. All right, so with 8 terms, notice the real part goes from 0 to 1, right? So we have our square wave. The imaginary part, well, we don't have all zeros there, but look at the scale on the imaginary part, 10 to the minus 15th. So this is numerical error, and for all intents and purposes, this is 0. 10 to the minus 15th is definitely 0. So you see, we took the 8 ingredients, added them together, and we got our exact square wave. This is different than continuous time. In continuous time, we need infinity ingredients to get our square wave. Here we only need 8. Now, I'm going to continue on in the program, and this plots the Fourier series coefficients. So this first plot, or this top plot, is the magnitude of the Fourier series coefficients, and the bottom plot is the phase of the Fourier series coefficients. So starting with the magnitude, the top plot, you'll see A0, the horizontal axis is K, so this is A0. A0 is about 0.6, a little bit more than 0.6. So that's the DC term, or that's the average value. Then we have 0.3. Remember, the AK is the amount of the ingredient. So we have 0.3 of the first harmonic. Then we have, you can think of these as like the number of cups or something in your recipe. 0.3 cups of the first harmonic, then maybe 0.1 cups of the second harmonic, third harmonic, fourth harmonic, fifth harmonic, sixth, seventh harmonic, and then it starts to repeat again. So here's the 8th. After capital N equals 8, the Fourier series must start repeating. Again, this is in direct contrast to continuous time. Continuous time, we see no such periodicity in the Fourier series. Discrete time, the Fourier series must repeat by capital N. Okay, so that's the recipe. That's the amount of each ingredient. And here's the phase. So the phase is telling us that, well, if you see the 0th harmonic is got a phase offset of 0. The first harmonic has a 0 phase, but the second and the third harmonics have a phase of pi, 3.14159. So they are pi out of phase with the first harmonic. And then the fourth harmonic, again, is in phase with the first harmonic, so it has a phase of 0. The fifth harmonic is out of phase by pi. Sixth harmonic is out of phase by pi. Seventh harmonic is in phase, and then it repeats again. It has to repeat. Okay, so you take all those ingredients, you take those phase differences, you take the amount of each ingredient, you put them in a bowl, you add them all those sinusoids up, and then you get your square wave.